Formation of ionic bond in terms of energy change. So this is actually known as Born-Haber cycle. As we have seen that any kind of bond formation is related to lowering of energy. So thereby the bond becomes stable. Here the stability of ionic compound is determined by a factor called lattice enthalpy. First we will see the definition of different parameters. After that, in the next video we will see the cycle of energy transfer, how an ionic bond is formed and how the energy is finally being lost in the entire process. So the first definition is sublimation energy. As you all know that sublimation is a process in which a solid is directly transferred into a gas, keeping just the liquid state. So here also the energy required to convert 1 mole of a solid substance into its gaseous state, that is called sublimation energy. If sodium solid has to change to gaseous sodium, whatever energy is supplied to this 1 mole of sodium is called sublimation energy. Now here keep one point in mind, whatever energy is being absorbed, this all are given as a positive sign and the energy released are represented as a negative sign. Coming to the next, that is ionization potential or ionization enthalpy. The energy required to remove an electron from the valence shell or ground state configuration of an isolated gaseous atom is called ionization enthalpy. So this sodium, gaseous sodium, will change to sodium ion with the loss of 1 electron. In doing so, whatever minimum amount of energy is required to be supplied is called ionization enthalpy. And this is also for 1 mole of sodium in gaseous state. Next is dissociation energy. Especially what we know that chlorine exists as a diatomic species. So when chlorine exists as a diatomic species Cl2, but in the formation of compound, it is the atomic state which combines. It is Cl which will combine, not the Cl2. So the bond in between Cl and Cl has to be broken. This is called the parameter of dissociation energy. So the energy absorbed by a covalent molecule in isolated gaseous state into its atomic state, of course 1 mole, that is called dissociation energy. So 1 mole of chlorine gas plus dissociation energy, we will get 2 moles of Cl gas and Cl gas, these are the atomic states. Then of course for getting 1 mole of Cl gas, we actually require half moles of chlorine Cl2, and of course the energy needed will be dissociation energy by 2. Next, coming to number 4, this is called electron gain enthalpy. As we know, it is the minimum amount of energy released when 1 mole of any isolated gaseous species accepts 1 electron to its valence shell to form an anion, univalent anion. Whatever amount of energy is released, this is called electron gain enthalpy. This will be energy released, so this is minus. Number 5, lattice energy or lattice enthalpy. It is the energy released when 1 mole of an ionic solid is formed from its constituent gaseous ions. This is called the lattice energy. That is when initial solid is formed from its constituent gaseous ion. What are the constituent gaseous ions? One is Na plus gaseous, another is Cl minus gaseous. So in doing so, whatever energy is being formed, this is called lattice energy. Now here I like to tell you one point, that since these are ions and also are in gaseous state, they have a very high thermal energy. When they are changing to crystalline solid, automatically their thermal energy is being decreased, and that lowering of thermal energy comes out in the form of lattice energy. Heat of formation. It is the amount of energy released or absorbed. Lattice energy is always released, but it could be absorbed, it could be released also. When 1 mole of a substance in its standard state is formed from its constituent elements, not the ions, at their respective standard state. That means when sodium chloride, its normal state is solid, ionic solid is formed from the elements. Na, this is in the standard state solid, and half of the chlorine in the standard state Cl2. So whatever energy is changing accompanying this particular formation is called heat of formation or enthalpy of formation. This can be exothermic, this can be endothermic, and finally it will only decide whether the formation of this will be feasible or not.